Today, we're going to veer a little bit from hardcore Ruby or straight core or straight and narrow Ruby. Crystal is a language, and Jon Egeland is going to talk about it. Crystal the syntax is certainly Ruby inspired, but it has some features that make it run really quickly and that kind of thing. And I mean, I'm not going to be able to talk about it all the way, so we'll let Jon go through it. And Jon, you feel free to get as in depth as you want. Little side note that Jon's been working on a language, his own language called Mist. Yep. It's implemented with Crystal. So it's kind of like a side thing that he's been working on, and he's having fun with it apparently because he talks about it a lot. All right, go ahead.
Cool.
Whenever you're ready.
Yeah. So I guess just quickly, I'm Jon, Gaslight developer. I've been working with Crystal for about 1.5 years now. I've probably written about 50,000 lines of Mist code, or of Crystal code, not Mist code, separate things. That's probably going to happen a lot. But yeah, so I'm pretty familiar with the language itself, and I figured I'd just give a quick introduction to the language itself, and then hopefully after that we'll go through some demos of stuff that I've written and look at how it looks and see how it compares to the similar stuff in Ruby. Do some quick performance-looking things as well, and then if anybody has questions or wants to see something like how would you do whatever you do in Ruby in Crystal or some other language, I'd love to answer those questions as well. It's pretty similar, but yeah, let's just go ahead and get started. So, if you want to follow along on your computers, it's pretty easy. Brew install Crystal lang. It should go fairly fast, and then you can just do this like Crystal run or Crystal eval, just like Ruby. There's no REPL. You can't get into IRB or anything because it's a compiled language, but this works well enough. If you don't want to install it, you can also go to carc.in, and that's like an online compiler that'll just run your code for you. It's pretty cool. So if you want to follow along, test out stuff as we're going, that's a great place to do it. So quick overview of what we're going to do. Pretty much what I said. We're going to look at syntax, brief overview of some of the different semantics from Ruby, look at a bit of the ecosystem, give some references, and then we'll do some questions as well. So what is Crystal? Well, it's looks and feels a lot like Ruby. You're going to notice that pretty quickly. And really, if you're a Ruby developer, you should feel pretty much right at home in Crystal right away. There's a few gotchas that'll get there, but we'll get over those later. It is statically type checked. That's part of it being compiled. So if you, similar to how Ruby is strongly typed, like if you do a string plus an integer, it's going to complain to you. Crystal will do the same thing, but it's also going to do that at compile time instead of at runtime, so you can catch those kinds of things earlier. And also it'll assert that when you call a method on an object, that the object actually has that method to call. So you should never really hit a no method error at runtime. That's not really going to happen. But one of the really nice features of it is that Crystal has type inference, so you're not actually going to be writing types too often. You'll do that just to really help it along and make things go a little bit faster. The nicest thing about Crystal, though, is that it compiles to native code, and because of that, it is fast. Very, very fast. Like I said, we'll get into performance a bit later, but that's definitely a major advantage, is when you want to write Ruby-style code, or that's what you were comfortable in, or you just have a decently sized code base and you want it to go a lot faster, Crystal is honestly just a great option. It's a pretty easy transition, and you get just instant performance benefits out of it. So syntax, it's, like I said, pretty much identical to Ruby, a few gotchas, and there's also a few new things to deal with types and stuff like that. So first thing is primitives. All your normal stuff, you got nil, true, false, integers, floats. The only important thing here is that you have char and string. So in Ruby, you just have single and double quotes, so the same thing, you get a string out of it. In Crystal, a char is a separate type, so more like C, more like Java. And chars compile down to 32-bit integers on the system, so they can run a lot faster and give you some good optimizations in some cases. But again, you got string symbols. Symbols as well are not runtime objects. They will also get compiled out into integers, so you can't really do the same thing where you would in a Ruby program, have a symbol and then call out 2s on it. That's not going to work in Crystal because it doesn't know what that is at runtime. Collection types, you have arrays and you have hashes, but then you also have tuples and named tuples. So arrays are just like in Ruby. You have an array. It can grow, it can shrink, you can do whatever you want on it. It can contain any types that you want. Hash is the same thing, but for key value pairs. Importantly, you have to do the good old hash rocket syntax. The other syntax is for name tuples. But again, any value to any key to any value, you can grow it, you can shrink it, you can splice it, you can do whatever you want. Tuples are the sort of static form of an array, so if you think more of like an array in C or something like that, that'd be more like a tuple. There's also some compiler optimizations that the language can do when you're dealing with tuples. So if you've done like multiple assignments, so like you want to assign A and B is equal to an array of 1 and 2 or something like that, or you get like multiple values out of a thing, you can do that with tuples, and then the compiler can do some cool things to make that run even faster than it normally would. But importantly, they're a static size. You can't add to them or take off of them. It's going to be like this one is going to be 3 elements long, and it'll always be that way, which is actually kind of nice. You'll with that guarantee, like the compiler will tell you, oh, you're returning a tuple here, but it's only a 2-element tuple instead of a 3-element tuple. So that's more of that type safety kind of thing coming in.
And hash, even if the keys are symbols, is different from a named tuple?
Yeah, so if you have, yes. So if you have a hash that has keys as symbols, you'd still have to write it in this syntax for it to be a hash. It would work the same way. You could access it with the symbol notation in the square brackets. That'd be totally fine. But yeah, a named tuple is something semantically different. Named tuples, honestly, I don't see too much of a use for them. In the code that I've written, I think I've written 1, really. More often than not, you end up using structs or classes, because it's essentially the same kind of thing. Especially with a struct, I'll get into that later, but they're a fixed size, they're passed by value, and it works about the same. And you can like define methods on a struct instead of just a named tuple. But yeah, so that's collections. Other stuff, you got classic range, exclusive ranges, regexes, and procs. Procs are a little funkier because you have to have types on your variables sometimes, but not super important at this point. When talking about types, you got module and you got class, just like normal. They do the same things as they do in Ruby, but then you also have struct. So if you're familiar with C++, C++ has classes and structs, and they're actually the same thing. They compile the same code. Here, they're actually different. So a class is going to be allocated on the heap. So if you're running a program, it's going to like call out, in this case, into the garbage collection, run a malloc call, give you some dynamic memory, and you get a reference back to that. A struct, though, is just memory directly on your stack, so in your call stack. If you take a struct as an argument to your function, you're going to have that data as the argument instead of with a class where you'd get a reference to that, and you would have to jump through that reference to get to the actual data. So structs are pretty useful, particularly when you want small data that you are going to not necessarily be copying a lot, because copying is going to take a little bit longer. But when you have small data that you really need just speed to go through with, like it's not going to have to call out, allocate memory every time, and redo that kind of stuff.
So it's not that struct is something it's not something you really want to like pass around a whole lot, right? Okay, I guess that's what
Yeah, there's some trade-offs. So if you have a really big struct, it's better off as a class, because you're only going to make one instance of it, and you'll just pass around a pointer all over the place. But if you have a struct that has like 3 properties, it's probably better to use a struct, because it's only going to be putting 12 bytes or something like that, and it doesn't have to make the memory call. But yeah, there's some other things with that. If you go read the actual language docs on structs, it gives a much better explanation of when they're useful. Yeah, that's pretty much types. You also have enums. This is sort of like the last kind of type. Enums are like a fixed set of values. So in this case, we have an enum foo that has possible values of 1, 2, 3, or 4. An enum, if you make an enum of type foo, it can only have one of these 4 values. And so the nice thing with that is if you've done like colorization with Ruby, you normally like use symbols, and you'd have like a symbol red to say that I want something to be red. But you could easily mistype that as like read or something, and you wouldn't find that out until you're running the code and it doesn't work. And it's like, why didn't it work? Oh, typo. Enums are cool because they'll, again, get caught at compile time, and you can actually compare them. So like if you have, in this case, 1, 2, 3, 4, I could say foo1 is less than foo4, and I'd get true because it came before it. So they're a little useful in that sense. I use them a lot just when I have a fixed set of values that I want to be safe with. It's pretty nice. Typing. This is sort of where we really deviate from classic Ruby stuff. Like I said, it's statically type checked, and you have types on things. So in this case, we have your normal instance variable from Ruby. This would actually be a class instance variable. Don't worry about it. This is actually an instance variable. And in this case, we're saying it's a string. So you use this colon and then type to say what type an object is. So in this case, we have a instance variable that is a string. We also have like age here is an int32. For numbers in particular, you have to give it a size so that the compiler knows like how many bytes to allocate. So an int32 is going to be 32 bits. Int64 is 64 bits. It does actually like use that optimization. So like if you make int8s, which are 8-bit, like a byte in most cases, it can pack those in and give you like better memory performance, stuff like that. Generally, you're going to use int32 because that's just what everybody does. But then we got this question mark after it, which means that it is nillable, and I'll get to that more in a second. But by default, things are not going to be allowed to be nil. So if you say this is a string, it's always going to be a string. It can't be nil, which is super nice. Typing works the same way in method parameters. So I can say that I'm going to take an argument name, and it's going to be a string. And as you can see here, actually, this is another cool part. I'm directly assigning to the instance variable. It's a little weird when you first look at it, but it actually ends up being pretty nice because you don't. If you take in 5 arguments and you need to assign those into your instance variables, you don't have to write the 5 lines in the body. You just put them right in the arguments there. So it's a little slick like that. Again, here we're just saying it takes an int32 that might be nil, assigning to the age thing, and then we're going to default it to nil. So default params work the same way. Same thing in other methods, and then this one, after the parameters, says that that's the value that it returns. So in this case, we have the greet method that takes a greeting that's a string, and we're saying it has to return a string. And we're doing that. We're returning a string with interpolation in there. If we had this, that applies to any return from the method. So if I had a conditional there that returned some different things, like potentially nil, or like returned a symbol in some cases or something like that, then if I said just string here, that wouldn't work. I'd have to specify all the types that it can return. And I'll get a little bit more into how that applies in a second as well. Macros are sort of another weird thing. So Ruby is obviously completely interpreted. It all happens at runtime, like it's doing everything on the fly. It doesn't actually make much of a difference. And compiled languages, you have sort of 2 phases. You have compile time and you have runtime, and actually that realistically gets split up into about 7 different parts at compile time, and then you have runtime itself. And so one of the early phases of compilation is expanding macros. And so what this does, if you're familiar with Elixir macros, it's very similar, or like preprocessor instructions in C. You define some function with a name that can take arguments and do stuff, and then you define what it's going to basically paste into your program. So if I have this define methods macro, I'm saying in some macro code, which is what these bracket % things are, iterate whatever arguments I was given to the macro, and then run this code and just like paste that in there. So if I ran this define methods with foo bar baz, it would automatically, like at the beginning of compilation when it's expanding the macro, it would end up saying, okay, well, def foo with some code in there, and then def bar with some code in there, and def baz with some code in there. So right after that, I would have access to 3 new methods, foo, bar, and baz, with whatever code that I put in there. Macros are super powerful because they basically get rid of a lot of boilerplate that you end up writing. Particularly, it's very similar to like what active record and active support do for you in Rails. All that kind of stuff can really be done in macros, which means that you have no runtime overhead. So you get like performance that you'd get if you were doing everything manually and exactly like writing your own methods for everything, but you don't have any of the overhead at runtime.
With macros, is it like, so in Elixir, macros enables Elixir to write a lot of Elixir in Elixir?
Yes.
Is the same true of Crystal?
Crystal is bootstrapped, so it has implemented itself in Crystal. Everything about Crystal is done in Crystal, which is basically an advantage of being a compiled language. It can do that kind of thing. It can write a binary that runs itself. Macros are actually pretty sparingly used in the language. They aren't very well, they're well supported. They aren't really pushed because they do contribute to higher compile times, because it has to run through this phase, see all the usages of your macros and expand the code, and then reevaluate that code that it generated, and it adds a few steps. And so the general idea is only use a macro when it gets rid of a lot of boilerplate code. Otherwise, it's just deal with it, write the code yourself. It's not going to be that bad. There are a lot of really cool macros that I'll show a bit later as well. Other stuff I'm not going to bother really getting to. Named arguments, that's the same as it is in Ruby. So like you can do your positional arguments, then a splat collector, then you can have named arguments that like you give a name to. And then there's some other stuff with that. Abstract types, so in Ruby, if you have an abstract class, like abstract doesn't really exist in Ruby, you can write a class and you can implement some methods, and then you can just by default say it raises something, and then you inherit that class, and then you like do the actual implementation. Abstract types are like the real way of doing that. So it's just, it says this is the template of a class. Whatever inherits me is actually going to give the stuff for this. Generics are kind of similar. Generics basically the same way that you sort of do type restricting. Here, you can pass types into generic containers. So like an array is a generic container. It can take in a bunch of different types, and like it'll make a specialized type. So like an array of integers is specifically going to be an array of 32-bit integers instead of being an array of arbitrary object, and then you have to cast it and stuff. So it's just a little bit more performant. And it does give you a few things. So like if you're implementing a node tree or something like that, you can have some generic stuff. Generics in particular are really just a performance benefit kind of deal. You don't really get much in the way of added flexibility. Most of that you can do with abstract classes. The last thing is free variables. It's very similar to generics, but if you want to make a method that takes an argument of any type, but then has to do something with that type, you'd use a free variable, and then you'd get that type as a variable inside your method, which is kind of cool. But yeah, I missed a lot of stuff, I'm sure. The Crystal Lang docs are a lot better, and if I was going to go through all the syntax rather than just like what's different from Ruby, I'd be here all day. So be sure to check that out if you're interested more in it. But let's move on to semantics. Like I said, I'm not going to cover much here either. I'm just going to glance over some differences. We talked a little bit about type inference already. We're going to do method overloads and how that's different. Type unions, which are really sort of the thing that makes Crystal great as a type system. And then dealing with nil. Like I said, things aren't nil by default. Type inference. So here I have an add method that just takes parameter A and B. That looks like pretty good Ruby, right? It's just add A and B and do whatever it does. So I add 1 and 2 and I get 3. I add hello and world and I get hello world. Pretty straightforward. I don't have to put any types there. Even though Crystal is statically typed, I don't have to say anything, statically type checked. I don't have to say anything about the types here. It can infer that, hey, you called add with an integer and an integer. That should just work. And so it does. But if I called this with nil and 2 or something like that, it would try to find the plus method on nil, because that's how plus is implemented in Ruby and Crystal. This is realistically a dot plus with a parameter b. But nil does not implement the plus method, because why would it? So at compile time, it'll say, wait, nil doesn't have a plus method. That's an error, and it'll tell you right there. So saving you the inopportune experience of seeing that at runtime and not being able to catch it. But yeah, so you don't have to write types there. What you can do, though, instead, is if you do want to write types, you can overload things. So here I have 2 different versions of add. This one in particular says A can be whatever it wants to be, I don't care. But B has to be a number to go to this method. This one is the other way. A can be whatever, but B has to be a string. So when I call that with 1, 2, it'll say, OK, well, I have an integer and an integer. A doesn't matter, so I can still match that. B has to be a number. Is it a number? It is. OK, I'll use this definition. So A plus B, that works because integers define plus. Same thing here. We have an integer and a string. Integer, fine, that matches. Oh, it's a string, not a number. Not going to match, so it's going to look at the next definition, and it sees that it's a string. So it's a bit, if you're familiar with Elixir, it's kind of like pattern matching. It's just signature overloads. It's not nearly as powerful as pattern matching, but you can think of it sort of the same way. But yeah, I would go to this method, and you have a different definition. And one of the cool things, not necessarily cool things, but interesting ways of how this actually works in the language is this does the same thing as this. Not just like it adds 2 numbers, but like when this sees the add method, it's going to say, I have 2 integers. I need a method to do that. Here's an add method that doesn't care what arguments that I give it, what type of the arguments that I give it, but it has 2 arguments, so it matches. What the compiler is actually going to do is generate a specialized version. So this is a method template. It's going to generate a specialized version that is specifically add with an integer and an integer. And so if I then call this add string with 2 strings, it'll say, oh, I have an add method that I've already specialized. Does that specialization match? No, it doesn't, because it takes integers. I have strings. And so it'll say, oh, I need to generate a new one based on this template. This is really just doing that explicitly. And because of that, we can add other code into the body of it.
So if
like add with one argument, it would not match. You can write one that does match. You can also do default arguments. So like you have kind of similar stuff, but it's not going to occur automatically. I think there's libraries to do that with macros. I wouldn't be surprised.
How would it type an array where you have like a bunch of different types of things in there? Like what would it do with that?
We'll get to that.
Okay.
Type unions.
And I'm guessing that number is some sort of union type over all your integers and floats and everything.
Yeah, so you have, in the hierarchy, you have object as the base type of everything, similar to Ruby. Then I'd mentioned like classes are different than structs. Classes are reference objects. Structs are value objects. Those are two different classes that exist. Under that, you then have number, and then under that, you have int and float, and then under those, you have all the like int 8, int 16, int 32, int 64. So it's a whole hierarchy. So yeah, a number is any numeric value. So that's overloading. There's a lot more cool stuff that you can do with this that I'm not showing here. One thing that you can do is dealing with nil, and I'll show an example of that when I go to demos. Type unions, this is what we're getting to. So this is another syntax thing I didn't cover, but if you want a union of two types, you give it with a pipe in between them. Basically what this says, oh yeah, property as well, I'll get to that in a second. We have a variable foo, that's a property of our class, and its type is either an int or a float. It can be either one at any point in the program, and it doesn't care when. It's going to say the type of foo is int or float. If with an array here, it is a type union of int and string. So I don't have to write any types there, which is pretty cool, but any object in this array could be an int or a string. Same with the hash.
Can a struct be a type?
What do you mean by a struct be a type?
So could you define bar as a struct with some fields, and then say property foo is?
Yes, yeah. So if we go back here, all these count as types. Enums also count as types.
Right, okay, cool.
All those four different types of
You can
things.
say this could be a number or it could be one that's, that's really cool.
Yeah. So you can use an enum as a type restriction. Similar like with the color thing I was saying before, like you could say that your method accepts a color object. Even though color is an enum, you can take in one of those. Cool. So yeah, like arrays, you get the union of all of the elements that are in the array. So if I added like a Boolean in here, then this would suddenly become an array of int, string, or bool. For hashes, you have separate types for the keys and the values. So this is a hash with a string key and an integer key. So the key type, which is this first argument, is string or integer. And it has values of a symbol and a float. So that's what the value types are. So they're distinct things, which is a little bit helpful later on. One thing to note with this is that if I make this array literal and I assign that to a variable, so I have it as an array object, if I try to then push in a Boolean or a nil or whatever else, it's not going to allow that because it's created an array of ints or strings. It doesn't know what a bool is in that array, essentially. We've made the generic type with that type union. One thing that sort of catches you up later on when you like deal with these types in your program is that when you use a union type, all of your code has to work for any of the types in the union type. So if I had like int or string or int as my type union on foo, or let's say it's like a name or something, and then I call somewhere else, I say like name.upcase. The compiler is going to complain because integer doesn't define upcase. That's not a method on it, right? So when you're dealing with a union type, you have to deal with all the possible types. And there are ways to get around that, and I'll show that with dealing with nil, which is right now. So I mentioned before a few times actually that types are non-nillable by default. You have to add the question mark to make it a union of nil. You can also just write it as a pipe. You could say pipe nil. We do the same thing. That's actually what the question mark expands to. And also, like I said, nillability requires explicit attention everywhere. So if you say something can be nil, you better deal with it being nil wherever you're dealing with it. It's not going to compile if you don't. So here's an example. We have some method that returns an int or a nil value. So the return type is this int or nil, right? And that's what a is. So here's a plus 1. We try to write that. Since a is a union of int or nil, and nil doesn't implement the plus method, we'll get a compile error. So how would we deal with that? Well, luckily, the language has some semantic behavior with like conditionals, where if a, nil is a falsy value, right? Nil and false are the only falsy values. So this condition will never be true if a is nil, right? So inside of this block, inside of the if condition, it'll say, oh wait, if A was nil, that's not going to work. So it'll take off the nil type from whatever you're doing inside here. So in this case, we had int or nil. Inside this block is only going to be an int. And if I had an else block on there, then inside that else block, it would only be nil. You can also use what's called the isA method, isA question mark, to ask if it's a certain type, and the compiler will do the same thing. It's a special method where if I said if A is a string or A is a float, then inside of this block, the type would be restricted to only being a string or a float. And then in other methods, it would say, well, it can't be a string or a float here, and it would take those off and leave you whatever else you had.
Can you do that with like is a and then enum?
Yeah, enums are full types. You couldn't say is A of a value of the enum, it would be the whole enum type.
Yeah.
And then you check the value of it somewhere else.
Nice.
Yeah, enums are first class, which is pretty cool.
Almost makes sense.
You almost get them. There is a set class, obviously, that does the same thing. So that's how it works with local variables. Sadly, instance variables are a little weird. They don't work quite the same way. So in a local variable, the scope of that variable is whatever scope you're in. So like if you're inside of a method, that variable is only going to exist inside the method. Instance variables are tied to your object that you're on. So if you have like an age property on a person class, that's an instance variable. The age instance variable is tied to the object, not whatever scope that it's in. It's not lexically scoped in that sense. Because of that, and because Crystal is very well designed for concurrency, it can't know for sure if the value will have changed or not when you're inside of different blocks. And so this won't work. So let's say, we say if name, and then we're inside of here, and then it's suddenly like, oh wait, I need to go run another fiber, or like you call something with IO blocks or something like that. It'll yield out to another fiber to be running at the same time, so you aren't wasting time on the processor. But it can't say for sure that by the time you come back, name won't have changed. Yeah, so if name is a string that might be nil, and it's an instance variable, this isn't going to work because it still might be nil in there. So it's not going to do the type restriction on instance variables. But there's a nice way around that. You just assign to a local variable. Simple enough. So this works the same way, because you're saying if a local variable name is equal to a thing, that's not going to be nil. It's a local. Restrict the type off, and it works just like you think. All this also applies to case statements, so you can do the same thing. So here's a method that returns int or nil. It's a local variable, so I say case A, when it's an int, it's only going to be an int inside of there. Otherwise, A is only going to be nil there. And you can do that with however many wins you want. Same thing with instance variables, though. Got to assign to a local. So if you want to restrict the type, put it in a local, basically. That's pretty much it for semantics that are really different from Ruby. There might be a few questions on it. Let me know if you have those. But yeah, if you want more in-depth stuff, there's a whole lot of things I didn't cover, particularly about some of the fancier things you can do with macros, the way that you can bind to C functions. So Crystal, actually, I'll just go show you the site for this part. Crystal lets you write bindings into C functions, into C libraries. So if you have like libgmp, which is how you do big math on a lot of computers, you can write these bindings, and then you can treat the C library as if it was Crystal code. So you can end up using it as like, oh, it's a module with some method on it. And I can just pass in values, and it just works, which is pretty cool. Yeah. So the goal, one of the goals of the language, I think they have it written up here, or not. One of their goals is that you shouldn't have to go into C to get performance. You should be able to just do it in the language itself. And they've done pretty well with that. You can also get the type of a value or a dot class to get the runtime type. A bunch of different things I didn't go into. I would recommend, if you want more of that stuff, crystallang.org/docs. And this is a whole nice, long series of things. So I'd recommend checking that out if you're interested. There's a database driver specification built into the language. So every database driver is going to follow this format, which means consistency is there for once. Somebody did it in a decent way. It's great. Yeah, semantics. So what's great about Crystal? I like it because you generally don't have to worry about types. It's pretty much like Ruby in that sense. You can just write whatever you want, and as long as it should work, it probably will. But if you want to, there's a pretty nice syntax for having control over those types. which helps a lot. I personally like writing types on everything. The general push is like, don't write types on anything because it's more flexible. I'm more of write the types on it, and then if I need it to not have the type, I'll take it off later. That's just a preference of mine. Because of those types, you get runtime type safety. You're not going to really have, no method for a nil-nil class. That's not going to happen unless you force it to happen. You can do things specifically to like say, yeah, I know this value is not nil, and then if you're wrong, you're going to get a runtime error. So don't do that. But obviously, the best part is that it's fast. Performance is really pretty crazy. I'll just show this graph right now. So I have a site up on Heroku that's running. It's been running for quite a while. And then I had a group of friends that I just asked to go like spam it for me for like a minute or so. And they got up to 12 requests per second. So I was pretty proud of them for that. But if you look at this response time, Heroku's messed up right now. The average response time, this is not a simple page. This is a page that's doing like 10 database queries, a decent amount of joins, and rendering a full page out. Half the responses go out in 4 milliseconds. It's pretty crazy. And the worst one was somebody on a slow network who just didn't get the response fast enough. So it took 120 milliseconds. And then the dyno load just like doesn't exist. It's like not even using the CPU at all. Memory is the same way, like super low hardware requirements to run really fast apps, which is great. What's not so great, a few things. Nil's still kind of annoying. More that you just have to write the code to deal with it. So if you think something might be nil, you're going to pay for it. If you know something's not going to be a nil, it can be pretty fun.
Could you take care of some of that with types, like writing your own maybe sort of?
Yeah, there are actually some monad libraries out there. If you want to do that, feel free. It's easier to just not use nil. It's a lot nicer to do that. If you need to use nil, the syntax does it pretty well, but you can also use type restrictions. So if like I was doing method overloading back here, I could have one that takes nil as a type and just like do nothing, and that would work. I don't have to like handle it outside. I can make the method take care of nil automatically. Yeah, typecasting can get pretty verbose, particularly things that have a lot of aliasing. So like if you're dealing with JSON, obviously a value in JSON can be an int, a float, a boolean, a string, whatever, array, a hash, like it can be whatever you want. And so that's a lot of types. And so if you want to say, oh, well, this value could be an integer or a string or a float, then you got to say int 32 pipe, float 32 pipe string. So it gets kind of verbose like that. But it's not the worst thing in the world.
Could you do an enum of types and then say it is one of these and JSON types?
You can do type aliases. Not really enums. I'll do an example of that when I get to the example. Union types make error messages a little bit harder to read, particularly when you're just like dealing with like, hey, I got an array of I don't even know what. Just like 30 different object types. You put them all in there. The error message you get out is going to be every one of those types split out with pipes. And if you have a recursive type alias, well, you're going to have a lot of words in your terminal. Thankfully, the way that the error message is formatted, it's actually pretty easy to read. You can at least tell what the error is. Figuring out why it happened is a little bit harder, but it'll tell you like, oh, there's no plus method defined for this particular type in that union. But yeah, they're kind of hard to read. And compile times are also not super great. This is definitely something that they're working on, but like C's got pretty fast compile times because it's an overall pretty simple language. Go's got pretty good compile times. Rust has decent compile times. C++ has really not so great compile times because of templates and stuff. Crystal's actually quite a bit worse than C++ still, which is kind of sad. But at the same time, I have a 20,000 line project. It compiles in 2 seconds, so like not a big deal. Yeah, that's pretty much pros and cons. Some ecosystem stuff. I figure we're Rubyists here. Some people do Elixir as well. You have the tools that you normally use. I try to give you some options in Crystal as well. So in Ruby, your dependency management, you use gems and bundler. In Elixir, you probably use mix and hex. In Crystal, you use what's called shards. Comes with the language. Works the same way. So you build a shard, you publish it on GitHub. They just host all their stuff on GitHub as whatever GitHub repo you have, sort of like Go. And then you do a shards install, and you get your dependencies. Obviously, you got Rails. Elixir is sort of like Phoenix is the complement to that. Crystal has a few. They're still developing. So because Crystal is so new in terms of popularity, it's been around for about 5 years. Really picked up in the past 2. People are still sort of deciding what they want to do. The biggest one right now, and my favorite, is Amber. It's really just a mix of the best things from Rails and Phoenix. So you get, your MVC kind of pattern stuff from Rails, but you get plugs and pipelines from Phoenix, stuff like that. It's pretty good. Lucky is pretty similar. It's by a guy at Thoughtbot. It's more just the Rails side. Doesn't really pick up as much from Phoenix, but it's still really good. For smaller stuff, you'd probably use Sinatra and Ruby, something like that. Elixir, if you wanted to, you could use Plug, I guess. Crystal, you use what's called Kamal. This is pretty much a Sinatra clone, essentially. Their site is actually pretty great. You go to Kamal CR. Their first thing, not their first thing, there's some graphs. So you can do 100,000 requests per second on Kamal compared to the same code doing 2,300 in Ruby. Response time, 400 microseconds versus 40 milliseconds. So that's performance for you for the same kind of code. They did a similar thing. I don't know if anybody here looked at Phoenix when they were doing like the road to 2 million connections. The guys doing Kamal did a very similar thing. They didn't have the hardware. They didn't get the 48 core machine. He had his quad core, and he still got like 1 million per second. So like, yeah, it's up there. And that's what you get with compiled languages. Like, because there's no overhead of a VM, any of that stuff, it can just run, and it's great.
Sidekick is built on Kamal?
So yeah, a lot of stuff that's in Ruby, people who need more performance. So like Mike Perrin with Sidekick, he needs performance in a lot of his stuff, and so he's ported Sidekick over to Crystal, and it's getting a lot of performance out of it.
Good to know.
Yeah, and a lot of things are moving that way. Yeah, so you got Kamal for active record or SQL, if that's what you do. In Ruby, Ecto is kind of the big thing in Elixir. Crystal, the 2 options are basically Granite, which is more active record style, and then Crecto, which is my favorite. I just love the name's great, and also it's the Ecto pattern, but done in Crystal, which is cool. Yeah, if you want to see more of this, there's an awesome Crystal site. Just Google awesome Crystal, you'll see that. There's tons and tons of projects. Actually, let's go look at that real quick. I can just hit the button. I think there was at one point, maybe.
Yeah.
There's a lot of things named, obviously, after different rocks. So you got Amber, you got Numite, Onyx. People are naming things randomly. Yeah, so like there's tons of stuff out there. It's surprisingly popular. I think the repo for Crystal has about 10,000 stars on it, 10,500. So it's definitely getting up there. And it's been around in its current form, like the current syntax and stuff, for long enough that people are writing, pretty big projects in it. So you got like things to bind to C, some CLI stuff, formatters, all your different database drivers. Where's the fun stuff? Where's one? Oh yeah, because you can bind to C libraries pretty directly, people just write bindings to like these massive game libraries that have existed for 30 years, and you can just use them in Crystal. Like, it doesn't even matter. You just do it. And it's actually such a common thing that there's a tool that automatically generates the C bindings in Crystal. So you don't have to do anything. As long as you have the header file, you can generate the C binding automatically.
Huh.
And it'll automatically link to it.
I wonder if anybody's done that with SDL.
Probably. There was one that I wanted to get to in particular. There's one. People are writing operating systems. That's what I was trying to get to. There's already an operating system in Crystal. Obviously, it's not like a big thing. It's not Linux-based or anything like that. It's just a proof of concept. But like, that's kind of the level that stuff's at, is people are writing really cool things. And there's some really big projects. The sort of like tracking site is Crystal Shards, which is exactly what they are. They're shards in Crystal. So you have like the most popular things of all time is Kamal's up there because it's been around for super long. Amber's right there, Lucky's right there. Amethyst is more like Rails. It's kind of older, but it's getting a kickback again. And Sidekick's pretty big as well. But yeah, things are going up there. Oh, I went off the site. Whoops. Let's go back here.
Oh yeah, yeah.
Somewhere. There. Okay. Demos. So let's look at some actual code. That was a lot of like syntaxy, semantic-y things. I guess first, does anybody have like particular questions about the language or anything that doesn't really make sense?
You said that Crystal had some built-in concurrency support.
Good question. So let's go look at the API. This is the docs. It's pretty similar to like hex docs, similar style. There's some improvements that I'm excited for. It's not happening yet. Some guy wrote this thing that automatically searches everything with a fuzzy search and like gives you all the results, and you can just like arrow key through them, and it's great.
Oh.
For some reason, it's not up here yet.
How to make also hex do that.
I'm pretty sure it's been merged, so I'm not sure why it's not out there yet. But yeah, concurrency. Let's actually go look at the docs because they're more accurate with this. Somewhere, concurrency. That's a guide for concurrency. Is it somewhere else? Probably not. Anyway, so Ruby, you have threads and fibers, and they're different things. So a thread is a native level thread. It's actually going to run like as a separate thing on your computer, and it can run two at the same time on different processors or whatever. Crystal's not there yet. They're sort of working on it. But what they do have is fibers. Same thing that happens in Ruby. A fiber is just what's called a coroutine or a cooperative thread, where instead of the scheduler, you're running a thread, and it's like, oh, 200 nanoseconds have gone up, you're done, pop out of there, I'm going to put something else in place. It'll say, oh, you're not done yet, that's fine, finish, do whatever you need to do, I'll wait for you to yield to me. And the standard library is actually built a lot around fibers. If you're doing I/O operations, every I/O operation is going to say, if there's a fiber waiting, go ahead and do that, I'm going to do this I/O operation. So it's automatically taking care of that. So a lot of times, even if you're writing, is there a good quick example here? Not fantastic. Yeah, this is a decent one. So like, I don't have to say yield here at all in the code. It's just going to do the thing. So this is going to spawn a new fiber and then send nil across. And then in the original fiber, it'll receive nil. I don't have to say like yield or anything like that because send is an I/O operation. And so it's like, oh, I'm doing an I/O op. Go ahead, yield out. I'll do that. So it's pretty transparent. You don't really have to write a lot of stuff on your end. Communication between fibers as well is done with channels.
Are fibers limited, like they are in Ruby, to like certain memory size?
I don't know. They might be. I know that the way that they've implemented them, I believe at least, I might be completely wrong, I remember seeing discussions about it, is every fiber has its own call stack, which I think is an 8 meg call stack.
Yeah.
I don't know if that actually has an effect on its memory size, but that's like its stack size. Any other questions before going into some other stuff? Cool. All right, so I'm just going to go through like some of these projects I've done, starting with a really small site. So this is just a simple webhook proxy. So we use Discord here at Gaslight as like our main communication tool, and it has the opportunity for you to push webhooks and get embedded data out of them. So actually, if I go into Discord, this is a risky click. Don't know what's going to happen. Let's go somewhere that I do know what's going to happen. Oh, stuff's happening. So I can get these embeds here that are like formatted messages, and you can put images and stuff on them. Not super relevant, but they have a webhook API. But things like Heroku, don't support Discord, because who uses Discord in the tech community? Actually, a lot of people do now. But it's not really a big enough thing. So like Heroku has like direct Slack integrations and stuff, but if you want to do anything else, you got to do like custom HTTP. And then it's for some reason not encoded in JSON from Heroku, which was really weird to me. It's URL form encoded, of all things. Yeah, it was really weird. So I wrote a proxy because I wanted to actually be able to use it. And this is basically, it gives you a key, you put the key in Heroku, it'll come into here, and then this will put out to Discord with the right JSON formatting. But yeah, so this is using Kamal. You get YAML and JSON for free in Crystal. All this does is, with Kamal, it makes a post, just like you would in Sinatra. So this is a post request to /create hook. I'm going to do some work and then return a hook ID, and that's the response that goes back out to the user. Here's another one to execute the hook. This is what you put into Heroku or wherever you're going. It'll take it in, say return a 204 because there's no content, and then run whatever the handler is. And these handlers, this is a good example of the type inference that happens. So here's a giant hash that could be a bunch of different types. I don't know what types are in this. They could be strings, they could be integers, they could be whatever. Here's a hexadecimal thing. Here's some booleans. I don't have to write any types on this. It just figures it out. It says, oh, I got this hash. Well, that's a JSON type here, so that could be any of the JSON types. There's also an integer, true, okay, sure. So at the end of the day, this thing is a massive type union. But I don't have to care. It just knows, which is pretty cool. Not too much else there. Oh, one syntax thing that I didn't cover as well is this sort of question mark style thing. So in Ruby, you know, you're used to seeing methods with question marks and with bangs at the end of them that sort of are like niceties of like, hey, this is like a query method, or like, hey, this is a dangerous, I'm going to modify you method. You can do that in Crystal too, but the main real usage of them is dealing with nil. So the same way that you would use a question mark to indicate something can be nil in the type, if you write a method with a question mark that's just like a getter, that means that it's probably going to be nil. The other option is to use a bang, which will do explicitly saying this is not nil, and it'll strip it. And there's sort of, I showed property before in the code, or in the slides. So if I have a property, foo, that's an int32. If I say that it's a property with an optional, like it could be nil, then whenever I do, you know, handler.foo, this is going to give me an int32 that could be nil. If I want to make that nicer for my users, there's also property question. So the property, first of all, is like addr accessor. It defines a getter and a setter. If I do property question mark, that means it's a query method, and it'll find the query version. That's more for booleans. So if I said like property, I don't know, is red, or something like that, this will define a query method. So this is like more of the Ruby style of like handler is red, and then it gives me back, you know, oops, true or false. Not types, true or false. But if I did a bang on the property thing, what we'd get instead, let's go back to an int32, that could be nil. We'd be given this regular method and the bang method as well, and the question method, I believe. So by default, actually no, we don't get question out of that. That's my bad. The normal accessor is going to give you int32 or nil, because it's just returning you the thing directly. It's like a normal accessor. The bang method is going to say that's no longer nil. It's just going to be int32. So it's sort of a shorthand for writing out what you would normally do, which is .not nil, which is that runtime thing I was talking about earlier, where if you do this and you like, it actually is nil, it'll raise an error at runtime. You don't want to do that. Don't do this, but use bang methods anyway, because conflicting advice. Hopefully that sort of makes sense. But question marks and bangs have a little bit more of a semantic purpose in this language. Anyway, so like.
Does it have the same runtime behavior? If it really was nil, if you did this red bang?
Yes. Yeah. I guess one of the bigger things with that is I had mentioned like if you did if a and then like inside of here a is whatever it is without the nil type. I said that works for local variables. It doesn't work for instance variables, and it doesn't work for methods, because if you call a method, it could be something different every time. So if you have a method that might return nil, you could assign that to a thing, or if it's like a property on an object, like handler.foo, whatever. If I just want to call, you know, handler.foo in here, that could still be nil. So what you often do is you'll write a query method to say, is handler foo not nil? Because it's like does it exist? That's the query method. And then the normal version will do the non-nil assertion. And so when you call it this way, it doesn't have nil on the type, which is a little cleaner. There's also the other the alternative, which is this way. It does exactly the same thing. Depends on how the code that you're using is written. But of course, you could, just like with instance variables, you know, assign that to A, and then you get the same behavior of stripping out nil. But yeah, so on particularly like with hashes, if you don't know if the key is going to be in there, because a hash can have any set of keys, you can take them out, put them in. Use the question method, which will return nil if it doesn't exist. If you take that off, then it's not going to be nil, but if the thing doesn't exist, it's going to raise an error. It's going to raise an index error. So if you want to ask if it's there, you do question. If you know it's there, then use the regular one. Here's a little bit of macro stuff. So up here I have this def handler, and then I give it a name. And then this is just like the block that handles the stuff inside of here. That works because I defined this macro called def handler, which takes care of the boilerplate. This is exactly what macros are for. What it's going to do is automatically make a class with whatever name I give it. So I gave it this name, Heroku Discord. And it's going to take that name and paste it in there. .id is just like you can pass it a string with quotes, or you can pass it a symbol. The ID is just the text of the thing, rather than with the quotes or the symbols. So it's going to make a class with that name that inherits from handler, then define this handle method, and then put whatever my block is inside this method. So I can define these like 6 lines of boilerplate code in one line in where I'm using it. And then I actually also put it into a constant hash as well. Similar, again, using an abstract class, like I mentioned. I don't want to have a default behavior for when I handle something, so I made it abstract. And so everything that implements handler has to implement this method with the same method signatures. Not too much on that one. Any like thoughts? Is there anything you don't like about the language or have a concern about? I'll happily address those as well. Let's undo whatever I did there. All right, let's go to another one. We've got, this is more of a decent sized application. The other one was built on Kamal. This is also built on Kamal. It's that site that I showed you on Heroku with the really fast response times. It's got quite a bit more stuff going on. This is actually like, structured in MVC. I've got controllers, I've got models, I've got views. And so just looking at a few things, I sort of made my own router. So like by default in Sinatra Kamal, you just get like get, post, push, delete, whatever all the other operations are. I made this macro for scoping, similar to like how Rails does scopes. And then I can just use these things inside of there. And I actually rewrote that with macros. I can go show that real quick. This one. So I just use macros to go for every HTTP method, just like pretend that I was writing an HTTP method at the top level, replacing whatever the Kamal one was inside of this scope, and handle the boilerplate. So I get whatever Kamal does, it defines this HTTP methods hash. So whatever version of Kamal is loaded into my application, if this library is also loaded into the application, it'll automatically generate whatever's in that hash. So if they decide, hey, we're not going to support delete anymore, then this will get rid of delete here, and I don't have to change my code at all. But again, it's all done at compile time, so these are like actually methods that get made. Same kind of thing. This is the method reference syntax. So similar to a method in Ruby, where you would, if you accept a block parameter into your method, you use an ampersand and then the name of the block that you're taking in. You can do that the other way around and pass it in that way. If you want to reference any method on any object, at least static objects, you can just sort of give it a reference. So this is in the accounts controller module, which is what these are. The controllers are all modules. The show method on that and the one that takes this environment thing. And this is just another alias to the HTTP handlers. So I just got a ton of routes in there. In the actual controllers themselves, you get your classic extend stuff. I can deal with environment things. Here's Crecto at use, classic ecto style. I want to get an association off of whatever object, whatever it's called. Here's a cast, so you have this .as, and this is where types kind of get annoying and verbose. It's like I have JSON, but I have this object here, this runner submission object, has these very well-defined types. They are strings or they are bools. Coming out of this JSON hash, when I look at that, that's going to give me back a type union of integer, float, string, num, or boolean, whatever object it fits in a JSON. But that's not what the method accepts. Max games is a string, so I have to turn it into a string. So I have to cast it .as string. It doesn't do things like C++ where it'll like auto fit the value into the thing. That doesn't work. So yeah, that kind of gets annoying, but it's not too bad. One way that I can get around this if I wanted to, I probably could do this. I had mentioned earlier that Crystal defines some macros for JSON. This is where the API actually works well. Nope, that's not what I wanted. There we go. So we go look at JSON. All right, let's look at JSON any first, or JSON type. So type is the alias. I mentioned aliases before, and it's this alias of all these different types. And it's actually recursive. So like a JSON type can contain an array of JSON types, and it's a little weird. Anyway, so JSON defines this mapping macro, which is honestly like the best thing that I've seen in a long time. So I have this class that has a JSON mapping of latitude and longitude for a location. That then automatically defines, well, I guess it's doing house in the example here. So house has an address and a location, and location defines this JSON mapping as well. This one can be nillable. That's going to automatically define this from JSON method for me. And because one of the things that is part of the JSON type as an alias is a hash of strings to JSON types, I can just pass it this hash of information, or I guess this is a string in this case, but whatever it is. I can just pass it JSON, and it's automatically going to give me back the house object parsed. I didn't have to write any parsing code or use a library to parse that out. I mean, I kind of did, and I had to use the JSON library, but that's in the standard library. And like it's just parsed, and it even like made the location object. It's not just a hash that put it at the first level, because it's going to recursively go through your JSON, look up the things that it knows about when you call JSON mapping, and like cast them into it for you. So that's super nice. And actually, one thing Crecto does there for the models is part of schema. If you're familiar with Ecto and Elixir, it's pretty much the same. Schema will automatically define that JSON mapping. And there's another one which makes it super useful for databases. That's db.mapping. It's exactly the same. And so you get this. That's part of the database specification that I was talking about in the Crystal language itself rather than the database adapters. So since they all use that protocol, you can just have your model define a database mapping and then say, hey, I want objects of this type, get all the right fields, put them into the right fields for me. So you get that sort of like active record style magic going on, but it's all pretty well defined, and you get solid type or type safety and everything. Super clean, super nice. I don't particularly use that directly too much because I'm going to use an ORM. I'm going to use Ecto style or active record style stuff on top of that, just because it's more fun to work with and a bit easier. But for library developers in particular, that's some really nice stuff. So yeah, model has schema, all that normal kind of stuff. Nothing too surprising there, I guess. There are some other languages on top of Crystal as well. So like you have your classic, like you have ERB in Ruby for embedded Ruby. You have EEX in Elixir. Crystal has ECR. It looks exactly like ERB. It works the same way. But then you have other languages like Haml on top of Ruby or Slim on top of Ruby. There are a few of those coming out in Crystal as well. So this one's called Slang. It's a lot like Slim. Really no differences, to be honest. But I wanted to write some clean HTML, and so I got that out of this, which was cool. And it actually handles like embedding JavaScript and stuff pretty well, which I was happy about. Not too much else there. Is there anything you guys want to see about web development in Crystal in particular? Nope. Okay.
Do you have anything like channels for teammates?
Like just WebSockets? Yeah, Kamal does WebSockets natively. Like it's part of Kamal itself. Crystal itself has HTTP WebSockets, so that's part of the standard library. Like WebSocket support is there. Kamal just makes them a lot nicer. So here's how you define a chat room. That's the whole thing. That's your whole server. You just have a client that runs on a socket, and you're done. And so you just have this WebSocket with whatever path it has, and then you just are given a socket object, and it works well.
Is there a JavaScript client for that also?
I don't know where it is, but there is one. This might be here. Is this the example? Yeah, it's just the Kamal example. It's just a normal WebSocket. There's no like layer on top of it on the client. Not like active record cables. There's like the specific JavaScript client that works with it well. That doesn't really exist here.
Okay. So there's not like a heartbeat protocol or something?
Not in Kamal. I think Amber might have one, and I don't know about Lucky. But it's just straight WebSockets.
Cool.
Check the Awesome Crystal page.
Yeah, check Awesome Crystal.
There you go.
Probably a lot of stuff there.
So you were asking like, this isn't web specific, but does Crystal support open classes? And do you have the same problem that you do in Ruby where I installed a library and now I have methods all over my classes.
Yes. There are open classes, and we were actually talking about this yesterday. Obviously, you know, like the push in Ruby is like, don't actually reopen your classes. Don't monkey patch things into the standard library. That's kind of not cool. But there are cases where it's kind of nice, which I'll go show now, because I can. So this is my language that I was talking about, Mist. This is about 20,000 lines. It's one of the larger Crystal projects out there, actually, at this point. But this is a good example of method overloads and open classes. So I have this base interpreter class that's inside the Mist module. And it has all these properties, and then mainly it defines this visit method, which is just the default. So node is an AST node, an abstract syntax tree node. And everything in the language, like an if statement or a variable identifier or an integer literal, those are all nodes in the tree. So node is the base type. By default, it's going to raise. And I could have done this as an abstract thing, but it's not actually an inheritance, so I didn't bother doing that. What I can do from there, though, is because there are like 80 different node types, I don't want one file that has all those things in it, because that'd be a super long file with all the implementations. So I have this nodes folder for each node type that defines an overload of the visit method with whatever the type that I want, the specific type. So this is a function capture node. If you're familiar with AREL and any of the implementation of it, it sort of tries to do this, and it does it really strangely. So it has visit, and then it's like the actual name of the method is visit something, like something node type, whatever. And then it calls that by its own like visit wrapper thing, and then that visit wrapper thing like does a send, like something send, and then it like interpolates like visit node type, something like that, and like there's a ton of overhead, right? You don't have any of that. This just happens at compile time, and at runtime there's zero overhead. It'll figure it all out. But this is where reopenable classes like make sense to me, at least. Like all these are inside of the interpreter class. Visit is a method of interpreter. And so because I want to split this across multiple files, I want to be able to reopen the class and just put the method that I want in the separate class. You do end up having the same problem with monkey patching. People are generally pretty good. Like right now, it's, you know, Crystal is not niche, but it's kind of niche where it's like the people who are really interested in keeping the language good are really in charge of a lot of things. So it's not really an issue at this point. I'm sure there will be problems, but it's definitely a push to not do that from the start, which is pretty nice. All right, one last thing. My favorite thing in Crystal. So I said it's performant. Obviously, as Ruby developers, we like TDD, test-driven development, and red-green refactor, all that fun stuff. And like I said, this is a 20,000 line code base, so I'm going to have, you know, a fair amount of specs. In particular, my parser for parsing the language is this very long file. This very, very long file. And this makes some good use of macros. Yeah, so this file makes some really good use of macros. So I just have this it parses macro, which takes in whatever the source code that I want to parse, and then I have some helper methods that I expect a literal node that is an empty string to come out of that. Or like I expect an interpolated string with a call to the method A inside of it for this one. So really clean, like nice stuff. This file alone has more than 2,000 specs in it, but the file itself is it's under 4,000 lines. So if I didn't have macros there and I had to write, you know, an it block with a do and then probably a new line or an end, it'd be a lot wider, that's for sure, and it would also probably be about 7,000 lines without the macros, because a lot of these expectations as well, like the implementation of this macro is probably 10 lines, so you could roughly estimate 8 lines per non-macro version. It's probably even longer than that. But that's not the fun part. I mean, it is fun. The fun part is when we go to actually run the tests. So let's get a new thing somewhere. And then we're just going to go ahead and run the specs. Oh, done. So I just ran, 3,400 specs in less than half a second. And those, these are not very trivial specs. We're making a new parser, parsing some code, probably interpreting the code for about 1,000 of them. There's a lot of stuff going on, and it just ran in half a second. Time crystal spec?
What's the wall time for that?
The wall time? With the, well, yeah, with the compilation time in there. It's a little bit longer. It's probably about 3 seconds, 3.5. Yeah, not that bad. So, a lot of times Rails and all these new things are doing hot code reloading, and it's pretty fun. The user time's higher than the wall time. Is that what you're looking at?
Yeah.
Yeah. Yeah, I actually don't know, because it's so that's one of the things in Crystal right now. It's not at 1.0. They're on 0.24.2. And one of the things that they want before they go to 1.0 is parallelism. They have concurrency, but not parallelism. So like I said, Crystal has fibers. They don't have threads because they don't have actual native parallelism. You can't run 2 things at the same time. So you get 1 CPU. And you still get all this performance out of it, which is insane to think about when you actually get to more CPUs, what it's going to be like. When I was talking about that 1.2 million connections per second thing on Kamal, I think he ran 4 instances of it. And they were talking to each other with some IPC stuff going on as well.
1 million for 4 instances is pretty good, considering like 2,000 Rails connections is like 32 app servers.
Yeah. So scalability, Crystal right now is very much in the out-of-process scaling, which arguably is a little bit nicer because you get some, third-party monitoring stuff in there as well. I'm not sure why that wall time is slower than the real time or the user time. That's weird.
Is the plan for parallelism to go towards something like Go routines, or?
That's why fibers are there. The
Yeah.
idea is that fibers will just run concurrently. I don't think there's any, so there's a thread class in Crystal, I think. Maybe they got rid of it. But it's an internal thing. You shouldn't have to deal with that. You should just be using fibers, and it'll automatically run them at the same time when they get threads working. The other thing that they want before 1.0 is Windows support. They don't have that yet. But that's getting pretty close. They've gotten stuff compiling there. But like file descriptors don't work on Windows.
Yeah.
You got to rewrite that whole library and a lot of other stuff. So that's 1.0.
Are there like any special hoops to jump through to like deploy to, it's like a simple deploy to Heroku? I mean,
Deploy
or
to
is it
Heroku.
used as like a is it used Cowboy or for like a web server or?
No, so the HTTP web server is built into the standard library.
Right,
It's
okay,
just HTTP server. In fact, if you go look at the Crystal site, not the API, Chrome's URL completions. Their first example, that's an HTTP server.
Right.
That's the whole thing. So you don't have any like other library beneath
Right,
it to do
right.
that kind of thing. I think most things are just using this directly. They don't really go outside because it's not like in Ruby where you have like WebRick in there, which is this sort of like bulky thing, and you want like some C code to, speed up the lower level things. Like it's already fast. It just works. I think I know Amber does some out of process scaling, so it'll like put up 4 instances of your application and do that, but that's part of Amber itself. It's not like Ruby where you'd be running on Puma
Gotcha.
or something like that. For actually deploying to Heroku, I can just go show you these metrics and stuff. It hides keys, right? Good, it does. Okay. That was scary. So there's just a Crystal build pack. You just put that on there, and then you just set up your Heroku remote push, and you're done. And
Cool.
it'll automatically take care of installing your dependencies and everything with shards. Oh yeah, I should show a shard YAML real quick. This is not a good one. I actually don't have any dependencies in this application. Shard YAML. So this is my YAML file. It's basically your gem file, but in YAML. So you have a name, version number, license, whoever your authors are, description. You can put like a website and some other information in there. And then your dependencies. And like I said, there's no like central repository for dependencies. It's just up on GitHub. And so I say, hey, I want the Kamal dependency. Oh, it's this GitHub at this organization and this user. Oh, I want Correcto, I want that. But oh wait, master's broken, so I want whatever they tagged as 8.3. And that'll automatically, when you do a shards install, it'll put them into your lib folder, so you have local copies, kind of like node modules. But then it also compiles some stuff and does some tracking. That's pretty much that. You also have dev dependencies as well if you wanted those. Be the same.
Does it?
Those are all by the default, the master branch on those things?
Yeah, it'll default to master. I think it might have changed. It might be like the latest tagged release. I don't actually know the specific details. I think it's master though.
Is there a way to grab packages from other SCMs other than?
Yes. I forget exactly what it is because I only ever
Okay,
pick them
cool.
off of GitHub. If we go look at,
So like if you could host something on GitLab or.
yeah, I think Git.
Yeah.
I think just Git will work.
Gotcha.
Does shard still exist as its own thing? It might have just been pulled in. Oh, it does. Cool. Yeah, so you can just give a Git URL to
Okay.
wherever you want to
Cool.
go. I don't know about actually local files. And you have the same like version matching if you want to do roughly.
If it takes a Git URL, you could give it a local, probably. I'd imagine.
Probably, yeah. Even just a local Git repository. One behind you.
So after all this, when do you find yourself reaching for Crystal for a project, and what made you decide to make Mist on top of it if Crystal's already got a lot of cool stuff going on?
I would like to do everything I do in Crystal at this point. If I'm just writing a quick script, so like Ruby versus Crystal is like the debate that happens all the time of like, oh, I'm a Ruby developer, why should I learn Crystal? Well, it's fast, so like that's one thing, but you do have types, so it's a little harder to use. In general, for me, the performance is worth it almost every time, and the actual overhead of writing some extra types and stuff, I kind of enjoy anyway, so it's not really a problem. So like, I think I've got at least 3 projects currently running, like side projects that I'm doing, running in Crystal that I'm working on, and I've had a few others, and it's like every new application I've done has been in Crystal so far for the past year, basically. As for Mist, why I would write Mist is the question, like on top of it. Different purposes, really. Mist started as a sort of proof of concept of like, I like parsers and compilers and stuff. I wanted to see if I could do it, and I could. And Crystal made it super easy, and then it actually worked, and then some people were interested in it, and so it just kind of kept going. But it's not a compiled language. It's not a statically typed language. It's fully dynamic, much more akin to what Ruby itself is, as opposed to Crystal. So like you have flexible types and stuff. And then there's some other some new things that I've put in there that I found to be just sort of nice. Like if you're coming from Elixir, in Elixir you have the cond construct, which is like a case, but it's a little cleaner and does pattern matching. Pattern matching is a huge thing in general. So I took that. Ruby, like in Ruby, you have one instance of a method. So if I define add on a class, I have one add method on the class. I can't redefine it multiple times. Crystal, you do that with method overloading. In Mist, it's all pattern matching, so you can define as many different clauses as you want for a function, and you can put whatever patterns you want in it, a lot like Elixir. So the reason I decided to do Mist was really just like, I like that a lot, I like Ruby a lot. Crystal doesn't really solve that side of the problem, it solves every other problem, at least for me. But I wanted to see something like that, and it was just really a fun project.
Cool.
You should put up the Mist site just so people see it.
Oh, yeah.
Just so they know what it is.
Sure.
All right.
Oh yeah, the new logo. I finally got a logo. I don't have a large version of it. Wait, no I don't. It's on my PC. We got a logo. Finally, that happened. I started this project about a year ago at this point, so it's been a while. But yeah, so it looks a little different, much more Elixir influenced than Ruby influenced. But like, here's a method that like contains, that calls each, and then you pass it a reference to this function. Like I'm passing this anonymous function into the method that has 2 clauses, and the first clause is whatever argument you gave to me as element, if that's what is given to this function, then it's going to match this clause, and if that's the case, then break true. And I'm sure that sounds really confusing without me explaining anything else about the language, so I'm going to apologize for that, but it's fun, and I get really excited about it. But yeah, like these 5 things are sort of like what I wanted and didn't see much of elsewhere. It's like pattern matching everywhere, multi-clause functions like that, and interpolations.
When can we expect a Mist talk?
Sometime.
Soon.
Maybe soon. I would love to talk about it more if people are interested, but yeah. Any other thoughts on Crystal? Anything you don't like that I could maybe give a counter argument to?
I don't like open classes
Don't like open classes. You don't have to use them.
or classes.
You don't have to use them. As you saw, like normally in a like Sinatra application or like in a Rails application, you're gonna have classes for controllers and stuff. Do I not have it open? I thought I had it open. I closed it. Okay. My controllers for this website are all just modules. They aren't actually classes, so they're just modules of functions. And I have to extend self because modules have instance methods by default, but I wanted those class methods. A little bit of work around it, but like this thing, the only classes in this are the models. Everything else is functional.
What is scripting like in Crystal? Like, is there...
Like a command line scripty kind of thing. It's not too much different. You're not going to be able, well, actually, that's a good question. I wonder now. Let's try something. Let's do this. I'm going to nano because I can, no, I'm going to sublime because I can. Okay. I already had that open, didn't I? Okay. Yeah, I'm so much not a Vim user that I use nano instead. Yeah, I don't like Vim. So let's make a thing. Let's try doing like a hash bang of user bin env crystal run. Let's try that. No, crystal eval. Does anybody know if it goes through standard input or if it goes as a string argument when you do a shebang? We'll find out. All right, so let's.
I was going to say Rob would know.
Standard, yeah, standard input makes sense. Okay, let's just try like puts hello, and call this thing hello putter, and then we'll go back over here, make sure that we have a hello putter. We do. Make it executable somewhere, and then hello putter. Unexpected dot. Did I have a dot anywhere? Where'd my Sublime window go? There it is. Okay, let's full screen this. I don't see a dot in my program. Or is that Bash complaining to me?
Oh, is that you don't need the dot in front of the slash?
No, because I'm running a local thing. Oh, there we go.
Hey.
So you can shebang it if you want. We'll just put a crystal thing on there. So I guess it's not that bad.
That's
if
cool.
that works.
So the reason I ask is like, I had a lot of fun learning F# with union types by writing a MUD.
Okay.
And I think that would be really fun to do in Crystal, and that might be another meeting, but that could be fun.
Yeah, for sure. There are a lot of CLI things out there. CLI like wrapper things. There's one called Admiral that's a lot like Thor, the Ruby CLI manager thing. There's also actually a lot of newer stuff is coming out. One of the awesome Crystal packages. It's called Nef. This looked really cool to me. It's like Make, but it runs things actually in parallel. If this GIF loads, there it is.
Wait, so the language doesn't support parallelism, but the build tool does?
This is out of process.
Ah,
It's going to spin
okay.
up new processes. But yeah, so like this is like a replacement for Make that you define with YAML stuff or something like that. But it runs shell stuff, and it's pretty cool. So like there's a lot of support for doing command line style
Okay,
things.
cool.
So it probably wouldn't be that bad. All right. Well, thank you for listening. Hope you enjoyed it and were intrigued. I'll definitely recommend make sure to go to references. Docs, API, both really good places. The Crystal repository itself, there's really active discussion about new things in the language. Everything's in GitHub issues and pull requests. Awesome Crystal, like I mentioned. They also are on Gitter. I'm not a fan of Gitter, but they're on Gitter. So that's where you can go. I think there's a link. Oh, yeah. Crystal is by a company called Monostech. I think they're in Argentina. I don't want to get that wrong. But a few guys there, they're the primary maintainers of it. They do really well, really, really smart guys. Done some really cool stuff. Where's Gitter? There it is. There's a link in their README. Lots of people hanging out there. If you have questions, they're definitely willing to answer.
What's the URL to Mist if we want to follow along?
Okay, I guess we'll do that. if you want that one, misslang/mist. Oh yeah, logo's here. There it is. Nope, there it is. Wait for it. There it is. Logos. Yeah.
Nice.
This is me cheating really hard. This is just a circle in Illustrator with a default pattern as the stroke. Yeah.
It looks nice.
Took me like 3 seconds. Took me a whole year and then 3 seconds. It was great. But yeah, Miss Lang goes to this. There's a getting started guide if you want to see that too. I spent a lot of time on this. So hopefully it's okay. If it's not, tell me so I can fix it. I'd like that.
There's also like a Discord community, right?
Yes, if you hit this community link,
Yeah.
we're in Discord. And
It's fairly active.
it's decently active. Oh, something happened. Ah, you were active in there. I see. Nope. Oh well. Yeah. That's it. Thank you.
Thanks, Sean. I don't know. I mean, I'd like to see if anybody has any like Ruby stuff they want to talk about, but and we're open to that. So if anybody has anything, great. If not, we can chat and just kind of hang out, whatever. I don't know. Yeah. Who's doing Ruby in their day jobs? Like, I know. Yes, Rob and me and you and Jeff. Yeah, so yeah. So, but yeah. Well, and Miles is still doing Ruby, so yeah. Cool. Ruby 5, Rails 5? Rails 5?
We were talking about some Elixir speed comparisons. I think before you got started, you were mentioning something about Mist versus Elixir or something, speed comparisons.
Yeah, I guess a little bit. At least compared to like Crystal, obviously Crystal's another thing, just because it's compiled. Mist, I haven't done much benchmarking for Mist. I took off the line.
It's a waste of energy anyway. Because like somebody's going to argue about like, oh, benchmarks are benchmarks, right?
It's been surprisingly fast. I guess if I can find this income now.
Yeah.
Do this. So I had those 3400 specs that were running in Crystal. They were written in Crystal. Please load. Please load.
It worked
Now it's
before.
gonna do the thing.
Right. Oh, wait. There it is.
Oh, look at that. So this thing hasn't worked, or it didn't work, and I have to like switch the input and back.
Wow, he showed this.
Yep, I did. Thanks, Shaq.
Yeah, I don't know if we're.
So we're back in. Oh, hey, a microphone. There it is. So if we run, I have a make file set up for this. So this is running specs that are written in Mist itself, and they run just as fast, which is pretty crazy. I guess if we time that, I think there's 520 specs, something like that. Well, so that's one thing that happened. I mean, there's only 500 of these compared to 3,400 of them. And the other thing that's not set up right now in Mist is buffer flushing for I/O. When you do a print, it doesn't flush the buffer, and so you're only getting, like, all these come out, and then it prints the new line. And it's like, oh, you printed some stuff, and then it actually puts it to the screen. So it's not quite accurate, but yeah, wall time's still like 2 seconds. I think a lot of that is that there's not as much of a standard library and stuff that has to get compiled and looked at runtime. So it'll probably get slower as things go, but so far it's doing well.
You were asking about Elixir versus Crystal.
Right.
So I know Kamal has some really good performance numbers and has come up pretty high on benchmarks.
Oh yeah, let's go look at some of the Tyobe, is that what it is? Tyobe index? No, that's not the same thing.
I think Elixir's performing only because of its concurrency and parallelism. It's not actually.
That's definitely a big part of it. Yeah.
It's a lot to do with parallel.
Although compared to Ruby's runtime, it does often in a single thread beat it out. What is the? Is it Tyobe? Yeah.
It's on the same like
Is it
order of
Tyobe? Maybe it's
magnitude.
Tyobe. Yeah, that's not it. Oh yeah, Crystal's going up here somewhere.
Yeah.
Somewhere. I don't know. It's in the next 50. Yeah. So this is like popularity. So of course Java and C are up there because history But then you got all the new stuff. So like, yeah, you got like Ruby is up there pretty high. Python's up there. Swift is obviously up there getting there. Delphi's going down. It's going down really fast.
Assembly's up there.
Yeah, surprisingly, like in terms, I don't know how they actually calculate this popularity. I think it's, I can hold the microphone actually. Yeah, sorry, I should have done that earlier. I don't know why I was doing that. I was like leaning over to you, like I'm going to talk into it. Yeah, I don't know how they calculate this. I think it's a large percentage is how much code's in the wild, rather than like survey results and stuff, which is why Java's like so high up there. Like it's so far ahead of, what did I do?
Yeah, so here, just read the second paragraph, right? And then the drop down just pops up.
We'll figure this out eventually. No, not Crystal Disk Mark. Crystal Lang
Plus,
benchmark. No. No. No.
Fibonacci, what's the Fibonacci benchmark?
I don't know.
Yeah. That's what everybody cares about.
There you go. That's a 48x performance improvement. That's clearly the bar is 48x or something. I don't know. This one's even faster apparently. There's some site, I forget what it is now. It's a really cool thing that's like some actual applications and they rank them in terms of performance. So like doing JSON parsing, like a decent chunk of JSON parsing, like response times to a certain HTTP structure kind of thing, something like that. A bunch of different things. Really, really big thing. I wish I could remember the name of it. There's links to it all over the place, but I don't remember any of them. But Crystal has some of the top results in there. It's actually gone back and forth. I think Crystal might currently have the fastest in the latest round. Maybe if I search R15.
Yeah, that's what I saw. So there's the new .NET web server.
Crystal doesn't have a Google Flu yet.
They didn't work on our SEO.
Tech Empower. Tech Empower. If you search Crystal Lang, it's generally pretty good.
Google made me know I could go.
Yeah. This is not like the one that's good. JSON serialization, maybe.
You know how they have Elixir guitar strings? Yeah. Like for like the first couple of years I was doing Elixir.
There's Crystal. That's surprisingly low.
The strings for guitars.
Hey, but if you're a guitar player and a programmer, you're fine.
Then yeah, I guess
It's like a different room.
There's other brands of other things that are worse than nothing. The Elixir shows.
There's Crystal there, the little one. It's like
There it is.
Oh, it's your one.
Yeah, so like it's pretty far up there in performance. If you compare that to like the first instance of Ruby or even Elixir, we're still going.
Cowboy is not fast as H.
I think that's Elixir. Yeah, that's Phoenix. But this is also in the cloud.
Yeah, the Phoenix.
So that's like,
This is and then it's right, like inevitably, whenever you talk about benchmarks, you'll be like, oh, this is not a good benchmark. And I remember seeing the Phoenix one, and it's like, not really, it didn't matter.
Nginx and Ruby, there's Nginx and Ruby.
there's Ruby.
where is it? Oh, wow. Somehow. I bet they used BSON or something, or like,
And Ruby.
Where's is Cowboy?
you can still run.
And Ruby's the little Ruby subset that's meant for embedded systems.
All right. Can you still run FFI on that though?
Why not?
Then it's probably using BSON. For JSON serialization in Ruby is definitely way slower than that. Or that's running like 90 processes. Because I think this is still on cloud. Yeah, let's go back to physical. What is? OJ. Oh yeah, OJ's a pretty good compilation thing. There's Crystal. Crystal Radix, yeah. Now we're definitely on top of Ruby. Not on top of Python though. That's surprising. Yeah. This is definitely lower than they were before. I got linked to something where they were the top one. Maybe it's, no, I don't know. I guess so. Yeah, they're doing well. That's basically it. Just gonna show it every time. Yeah, you got to show the chat. Yeah, yeah. This is great, low latency. I check it every 10 minutes, just like Twitch. Yeah, I guess if you want to get like involved in Crystal, I'd love help on Mist if you're interested. I definitely love to help people get into Crystal as well. So like, if you want to go follow that, hop into the Getter. Tons of people want help on their projects. A lot of stuff's pretty easy to get into. Like I said, people are super willing to help out. In particular for Mist, I'm trying to make it so that like, if I make an issue, I don't have any recently. Let's go to GitHub. I think I got this. Not pull request. Let's go to issues. So I try to do my best. I mark things with like this. Where is it? One of these says, that one. Yes, good first issue. I try to explain like, I want something done, and like some stuff about how to actually go in and do that, and like where in the code base it should go. If any of that's confusing, obviously I'm always on Discord too. But yeah, I'd love help with even just like checking it out, finding bugs, filing issues. There's cool stuff. Watching me write Mist code on Twitch. I haven't done it much. I did it once, and it was okay. I didn't know what I was doing on that one. I just sort of went into it like, I'm going to work on an issue instead of having the issue that I wanted to work on. I should have done it when I was doing the match operator, because that was a really fun one. I don't have much that I want to do now. But yeah, that happens sometimes on Twitch. The Discord's the best place to be, honestly. Updates happen there.
He's got his Twitch brand.
Yeah, they're separate identities. Cool.
Any questions? Everybody good? Everybody? Yeah, good. Cool. Awesome.
Thanks, John.
Thank you. Well, this will be the actual end. Maybe.